Yesterday, we spent almost all our time talking about irrational numbers. That's all we talked about. But we were using our brains, calculators, yeah. Okay. Irrational numbers are not rational. That's the definition of irrational numbers. Are not rational. That's your definition. Boom. Are not rational. Great. What does it mean, though, to be rational? So we need to understand the rational definition of numbers. Don't give me, it makes sense or whatever. No, it's beyond that in math. What's a rational number? Okay, Marshall?
A number that can be turned into a fraction.
Yeah, a rational number. So you need to write this down again. This is chapter 1 stuff. We're going to review it because if I don't understand what a rational number is, I don't really know what an irrational number is. So a rational number is a number, and there's a key phrase, that can be written as a fraction of, here's another word I'm throwing in there again, integers A over B, where B cannot be, do you guys remember what B cannot be? B cannot be 0. B cannot be 0.
Wait, equals not.
Yeah, that means does not equal 0. So B does not equal 0. So that's what a rational number is. So the technical definition for an irrational number is a number. So an irrational number is a number that there's just one difference, that can not. That's it. You just put not be written as a fraction of integers A over B, where B does not equal 0. That's it. Sorry? No. Just if you know what a rational number is, hopefully you can change it irrational. IR cannot. Done. You're like, what does that even mean? Okay, there are some numbers that we've dealt with that cannot be written as a fraction of integers. You can't write it as a fraction. And those are considered irrational. So let's go through some examples. Make sure you write this down, and then we'll go through some examples. Okay, I'm going to move on. All right, here's an example. The square root of 13. The square root of 13 cannot be written as a fraction of integers. But can it be written as a fraction?
Yes.
Whenever you have a number and you want to write it as a fraction, just immediately, what do?
You put it over 1.
Yeah, you can just say over 1, right? Oh, see, Mr. A, you can write it as a fraction. But are both numbers integers? 1 is an integer. Is the square root of 13 an integer? No. So, although you can write it as a fraction, it won't be of integers. I'm going to put an equal sign here. The square root of 13, Ethan, can you please give it to me? And say it slowly because I'm going to write it down.
3.60555 1275.
I'm going to put these little ellipses. What do ellipses mean again? It keeps going on forever. But should I just put a little bar over something? Like, do I put that little... Well, what about the 5s? They repeat, right? Can I just put one here?
They don't repeat forever.
It doesn't repeat forever. Guys, does this number ever repeat itself? Just think about it. Just looking at the number so far, does it ever repeat itself? No. Does it ever end? No. It's irrational. This is an irrational number because you can never write it as a fraction of integers. Like, if it stopped at 3.6, let's say it stopped at 3.6, could you write that as a fraction of integers? Yeah, it'd be a mixed number, 3 and 6/10, which can be converted. Okay. What if it was 3.605? Could you write that as a fraction of integers? Yes. Any terminating decimal number could be written as a fraction of integers, but this is a non-terminating decimal. It doesn't ever end, so you can never write it as a fraction of integers. Yes, Olivia?
Do you have to put 3 ellipses?
Yeah, 3 is a standard. Yeah, 1, 2, 3. Yeah, if you put 4, you just went too far. If you put 2, I don't know what you're talking about.
Wait,
Maybe you just meant to put 2 periods. Or you mistyped 2 periods. But 3, it's very clear it keeps going on in some pattern or some method. Uh-oh. Yes, Alex.
Couldn't you have done 3.606 since the 5 would leave the 5 up?
Yes, but then what would you have to change this right here to? Not an equal sign, but a little approximate sign. So approximately, yes, you can get a rounded figure, but 13, square root of 13 exactly is never going to be a terminating. But that's a good question. Yep.
we got the ellipses in English class.
Oh, really? Nice. And you use 3?
Yeah.
Okay. Yeah, I think that's just the way you write it. 1 is a period, 2 is a mistype, and 3 is ellipses. 4, you're trying to make a point. Okay, yes, thank you, bye. Okay, here's what I want you to write. Oh, non-terminating, and then I'll get your question back there. Non-terminating, non-repeating numbers are irrational. Non-terminating, non-repeating numbers are irrational. That's a key definition. Basically what you're doing in your homework tonight is they're going to give you a number and you just tell me if it's rational or irrational. That's it. That's all you're doing. And I do want you to write the word out. Please don't say, can I just abbreviate? No. Rational. Why? No. Irrational or rational.
Because if you write down rational, that, like if you abbreviate rational, you might think
I might think you're saying rat. What are you talking about, rat? Okay, anyway. Or irrat. Or ire. Which is something else. Okay. Let's look at another number that's special to us. Pi. On March 14th, 2020, we will celebrate Pi Day. That's a long time, by the way, from now. Actually, it seems like a long time, but it'll come quicker than we think. But we're going to celebrate Pi Day, and you will have pie that you bring. And you bring it for the 8th graders. And the 8th graders enjoy your pie, and you enjoy your pie. And then next year, those lowly 7th graders will bring you pie. So.
Are you required to bring pie?
No, you don't have to. You can bring, and I'll have sign-up sheets. I'll have you bring toppings or plates or napkins if you just to help out. Okay. Oh, that's fine. That's cool with me. Yep. Yes, sir. Sam.
That's what I like.
I'm just as confused as you are. How about that? Okay. If you have it, let me know. Marshall.
Star Wars here is the main title slide.
Sorry, Star Wars the what?
The main title slide where it has the words and it scrolls up.
Oh, yeah.
At the end it has ellipses, and all of the words is four.
Really? Which one does it have 4? Or sorry, which one does it not have 4? Do you know? That's a trivia. Oh, I think they said all but one.
All of them
All
have
but the
four,
first one.
but one of them has 3.
Yeah, and I want to know that one. The one that, yeah, I need to know that one now. Okay. All right, pi, guys, is this value right here. And some of you may know this because you've memorized. All right. 3.141592. 65. All right. Dot. The book gives you I think the book gives you about 20 decimal places, maybe more.
I was one digit off. I did that memory. Got like a piece of candy.
Yeah, and I did the same thing in my old school back in Denver, and someone memorized 100 digits after 3. I was sitting there with the paper, and they kept going. I'm like, you got to be kidding me, and they got it. They won a My Pie gift card.
Camille got somewhere around.
Well, you got like 200.
200. Oh my goodness, that's a lot.
Not 200.
That's amazing. Yes.
It was. Are you did you like have long? I remember I was like
No, I'm not going to do that.
Why? Wait, you're not gonna do what?
Because I don't want you to use up all that knowledge, all that brain power.
unlimited brain power.
Although it's not bad, I'm just
Most people remember from last year.
I want you to focus on what type of pie you're going to bring. That's what I want you to focus on.
Yes.
Yeah, Marshall, go ahead, and then we'll move on.
I'm gonna calculate a pi. I don't know how to do it.
You can get even further than that, and there are little programs where you can find any string of numbers in pi. So like if I wanted to find where are 1, 2, 3 in that order, 1, 2, 3 in that order, you can find it somewhere in pi, and it'll tell you it's the 1,000th digit of pi, whatever. But your birthday, your favorite numbers, yeah, you can find them. They're just all over. Yes.
Can you say as much of pi as you know?
3.1415. That's it. 92, 92, 65, 665, 9. Oh, whoa. Okay. This, guys, is irrational. Somebody tell me why it's irrational. Raise your hand. Tell me why pi is irrational. Remember, pi equals this number, and why is it irrational? Olivia? It doesn't end, and it doesn't repeat. That makes it irrational. So pi is an irrational number. Okay, let's go with a few others and see if we can get some of these down. Okay, so pi, we're going to call it irrational. All right, now let's just go through some examples so you guys know how to figure it out on your own. All right, 6/7. Can you write 6/7 as a fraction of integers where b does not equal 0? Can you write this as it is a fraction, so it's already written. Is it a fraction of integers? So you're going to call 6/7 rational. Please, I hope I did not insult anyone by saying that. All right, the square root of 8. Rational or irrational? And you're like, I don't know. Okay, here's a little hint. It is irrational because, so I'm going to put irrational. It is a square root of, and write these down. These are your notes, guys, so when you do your own homework, you're like, wait, how do I know if this is irrational or not? But it's a square root of a non-perfect square. So remember everything we talked about yesterday? We were talking about non-perfect squares being square rooted. All of those were irrational. But Mr. A, we rounded them to 13.2 and 2.5. We were able to do that, yes. But we rounded, we cut them off somewhere. Their actual value is irrational. Right? All of them. All the non-perfect squares square rooted will give you irrational numbers. Every single one of them. Except, wait. Every single, wait. Yes, every single one of them. Yes.
Can you elaborate on that?
This right here? All right. If you have a number here that is a non-perfect square, so 1, 4, 9, 16, if it's not one of those numbers, then if you try to get the square root of that, it's always going to be irrational. So if I said, actually I'm going to go to the next one. The square root of 25, is it rational or irrational? Don't call it out, but question?
Yeah.
Go ahead and figure it
So if
out.
all of the irrational ones, they're,
Square roots
all
of
the
non-perfect squares.
yeah, all of those are irrational, right? So then all of those would be rational if they're perfect squares?
Now, do you know why? Remember, what's the definition of a rational number? It can be written as a fraction of integers, right? You're like, that can't be written. What's the square root of 25? It equals 5. And can 5 be written as a fraction of integers? Yeah. So it can be written without changing its value. It's rational. It's a square root of a perfect square, rational. Now, let's say you're on the quiz or test, and I give you one, I say the square root of 225. And if you didn't memorize your square roots, your perfect squares, you're like, 225, oh, that's got to be irrational, right? Because it's a non-perfect square. But if you memorize the list, 225 was on that list. I need to know that, and I'm square rooting it. I know it's got to be rational, right? Because it's a perfect square. So that's rational. All right, let's keep going here. Oh, let's get tricky here. Rational or irrational? No, don't call it, sorry. Kind of write it down. Write it in pencil because we make mistakes. You got to erase.
Or you could use invisible ink,
Yes.
because then no one can see it.
Not even you. Okay. Aiden, what do you think? Is it rational or irrational? What do you think? And so I'm asking, can this be written as a fraction of integers? Yes, rational. No, irrational.
Irrational.
Irrational. Anyone want to say differently? And then you got to give me a reason why. Ethan? So what do you think?
3/10.
I mean, you could if you rounded it, but it would change the value just slightly. This actually is a common decimal that you should, by now, start memorizing. 0.3 repeating is actually a fraction of integers. It's 1/3.
Oh,
Do you remember that? 1/3?
no.
Okay, ready? So you can write this down, 1/3. They're equal, exactly equal. By the way, can you do 1 divided by 3? 1 divided by 3. On his calculator, just to verify, what do you get?
It's just a bunch of threes.
It's 0.333333333. What's going to happen? It doesn't end there, but what happens, do you think, after that? Keep 3333333. Okay, 1/3 can be written as 0.3 repeating, so here's what you have. Okay, it is rational. And here's why. It is non-terminating, right? It's non-terminating. It keeps going. But it does what? It does repeat. What do irrational numbers do? They don't terminate and they don't repeat. So rational numbers, they can also be non-terminating, but they also do repeat. All right. Anyway, let's keep going. So you're like, huh? Do you get me what I'm saying there? Because I'm going to give you more. I'm going to give you more with that. All right. Let's go to the next one. Ooh.
No, that's not a good time.
2.010203004 ... Okay. We're going to ask ourselves, can I write this as a fraction of integers? Okay, I don't know. Does this number terminate? Does it end? You know what terminate means? Does it end? Now, how do I know that? ... But does it repeat? How many of you see a pattern? When I say there's a pattern, that doesn't necessarily mean it repeats, does it? Okay, so does this end? No, it's non-terminating. Non-terminating. Does it terminating? Does it repeat any digits? Does it alternate? And does it repeat any digits? Okay, it's 0, 1. Does it say 0, 1 again? 0, 1, 0, 1, 0, 1, 0, 0, 2, 0, 2, 0, 0, 3, 0, 3, 0, 4, 0, 4. It's a pattern, but it's still non-repeating. That's a tricky one. It's non-repeating. So it makes it what kind of number?
Irrational.
It's got to be irrational. Irrational. Yeah, I'm so picky on these. Yes.
So it would be repeating if it was just 0.04.
Yep, if it says 0404040404, it's repeating and non-terminating, still
What
rational.
if it was like something crazy like 5, 6, 1, 2, 3, 8, and then 5, 6, 1, 2, 3, 8?
And if you could put a bar on that 5, 6, 1, 2, 3, it would be repeating and therefore rational. And there are numbers. That is a number.
For real?
Yeah, kind of think anything in your mind, any decimal number in your mind. It's a number, any number.
Can I say mine?
No. All right, here's another one. 0.121212221222. Yeah, you need to write this because this is going to help you to understand on your own if it's rational or irrational. Again, guys, your homework, you just put rational or irrational. That's it. But you got to know what you're talking about. So first of all, Alex, does this number terminate?
No, sir.
Okay, so we call it non-terminating. So you're like, oh, it's non-terminating, and it automatically means it's, nope, it doesn't mean it's anything. It's still either rational or irrational. Does it repeat any digits forever?
No.
No. Is there a pattern though?
Yeah.
But that doesn't mean it repeats the digits over and over. So it's non-repeating, and therefore, it's what type of number? Irrational. Irrational. All right, let's go. Yes, sir.
Is the next one going to be negative the square root of...
It could be, but maybe not.
Marshall, why did you give him an idea?
No, because that is the next number. Yeah, I'm pulling all these numbers from the book. So you're like, Mr. A, we don't even look at the book. I'm looking at the book right now.
0.13.
All right, here's the number. It's a fraction, right? As it's written, it is not rational because you don't have a fraction of integers, do you? This is not an integer, that's not an integer. But that's not what I'm asking. I'm saying, can it be written as a fraction of integers? Can it? Without changing its value, can you write it as a fraction of just integers? Okay, how many of you say yes, you could rewrite it as a fraction of just integers? Some of you, how many say no, can't do it, they're just decimals? Okay, ready? I'm going to rewrite it and you tell me if I'm right or wrong. All right, can I write this as 2 8/10? And can I write this as 13 hundredths?
That's not an integer.
Yeah, not an integer yet. You're right. But can you write this now as a division problem without changing the value? Is this a division problem? Isn't it 2 8/10 divided by 13 hundredths? And if that's the case, you can rewrite this as 28/10. Remember state change opposite, or state change flip?
Wait, but it's 13 goes to 280 evenly. So
It doesn't matter.
Because is this a fraction?
Yeah.
Is that an integer? Is that an integer? It's a fraction of integers. So it wouldn't go evenly. You would have a mixed number, but can it be written as a fraction of integers? Yes. You want a shortcut to get here? It's kind of funny. You want the shortcut? You do it all the time when you divide. Remember when you divide by a decimal number, you got to move it so that it's not a decimal number you're dividing by? Do you guys remember that? Okay. Yeah, why don't you just do that? This is your divisor, 1, 2, 1, 2. You got 280 over 13.
how do you know how many places to put it back there?
Good question. The 13, you want this number to be a whole number or an integer. Twice here.
Bottom first.
Yeah, you don't have to, but you can. You can do both.
Click them off.
So if you start with one of them to get it a whole number, that's how many times you need to move it on the other one?
Yeah, and here's the rule. If I move it twice down here, I got to move it twice up here. If I move it once up here, I got to move it once down there. So you just got to move it the same number of times. And you can move either way. If you want to move it back, you can do that. Just make sure you do it both same amount of times. That's manipulating numbers.
Are we doing homework?
I hope so. Yes.
So would that work on like most of our problems tonight if it's like?
Oh, yeah, actually, all you had to do here, Alex, is you just had to look at the original problem. Is it rational and irrational? And you could just think through it. Could you write it as a fraction of integers? I could. So just write rational. That's all you have. But I'm just showing you why. Okay. Oh, we're almost done. The square root of 12 over 13. Actually, you know what? I'm going to write it differently here. And I'm not going to use 13. The square root of 12 over the square root of 16. I'm going to use what they use. Okay, time out. As it's written, is it a fraction of integers? No, right? Could you write it as a fraction of integers? Do you know why you could or could not? I don't want just yay, nay, and then you don't know. You're just kind of like stuck. Yep, Sam?
Well, now that I think of it, one of those is going to be non-terminating.
This is going to be non-terminating, non-repeating. So this is going to be irrational. And you can never write an irrational as a fraction. So yeah, this one's 4, isn't it?
Yes,
So you can kind of do this. You can do this. But will this ever turn into a rational number? So you call it irrational. All right, do this one here. And don't be tricked. This is hard. We haven't dealt with fractional square roots.
Hey,
I don't
see myself.
Wait, is it?
It's the square root of 4/9. I'm thinking of a number. What number times itself will get me 4/9? Is it even possible? I mean, is that it? Oh, don't say it. You can hold your hand up, but don't say it. Is it possible? I don't know.
I know it.
Maybe. There's a rule here. This is actually Algebra 1 stuff, where we can look at a little rule, and then that can help us out very quickly, but we'll see. Danny? Okay, first tell me if it's rational or irrational.
It is
Rational.
Okay, it is rational.
Oh.
Okay, and then, shh, Danny, that's not a fraction of integers. That's the square root of 2 integers, but what'd you get?
It's 2/3 because 2 times 2 is 4, and then 3 times 3 is 9.
Oh, does anyone know what the square root of 4/9 is? It is 2/3.
It's in the book.
And it's a rational number. Yeah.
Oh, the numbers.
Are perfect squares?
Let's say, yeah.
Uh-huh.
Like 121.
Here, I think I know what you're saying. You're going to give me an example. If you have the square root of a fraction, and both the numerator and denominator are perfect squares, and really anytime you could do this, but you can just break it down into these two. Well, what's the square root of 4?
2.
What's the square root of 9?
3.
So it's 2/3. And you check it. Wait, 2/3 and 2/3. 4/9. That's a rational number. Last one, and then I'll let you go. -14 pi.
What?
Okay. What's going on between -14 and pi? They're being multiplied. Okay. You know -14, that shouldn't be too hard to think of, but pi, what kind of number was that?
0.
Okay. What's an irrational, non-repeating, non-terminating, times a rational number always going to get you?
An irrational.
It's always going to get you an irrational number. Anytime you're multiplying a rational by irrational, you're going to get an irrational.
Wow.
I know. It's that cool. All right.
Wait,
I'll put the homework down here. Homework, numbers. I'll put 2 through 24 even. Guys, use your notes because some of the problems are almost exactly like the problems in your homework. 47. Exactly.
wait, you did just 2 through 24.
So you can see it.
Oh.
Bye-bye, Swivel.
Bye.
Bye-bye, Swivel. That's my outro.